Hello, everyone, and thank you for joining us today for the APsystems DS3 and QT2 webinar. Just a few quick items before we get going today for any newcomers. During the webinar, all attendees will be muted for best audio quality. If you have any questions throughout the presentation, feel free to use the Q&A button at the bottom of your screen to type in your questions. They will be monitored. This webinar is recorded and will be shared with all of you within a few days. And it is my pleasure to introduce our today's presenter, Chris Ling. Chris is an applications engineering manager at APsystems, where he leads the AP Storage residential energy storage program and supports microinverter training. Before joining APsystems, he spent 6 years at Arc Systems, a Silicon Valley startup focused on manufacturing data analytics, working as a hardware engineer, applications engineer, and engineering manager. Chris holds both a bachelor's and master's degree in electrical engineering from Stanford University. And without further ado, I will pass it over to Chris to get us started. Thanks, Chris.
Great. Thank you for the introduction, Tatum. Hi everyone. My name is Chris Ling. I'm representing AP Systems here. And today I'll be going over the DS3 and QT2 things. Some of these might be topics that are quite familiar to everyone, but I hope to introduce a couple of new topics as well with regards to AP Systems. Just as a quick company overview, as a quick company overview, AP Systems has a pretty large footprint all around the world. Most importantly is Canada, of course. But our headquarters is in Jiaxing, China. I believe our first outside of China business unit is actually in the United States in Washington. And then we have other business units within Europe and Australia and Mexico, Brazil. And as mentioned earlier, Canada is where our favorite business unit is. We have a pretty long history starting from the year of 2010, is where we started setting up our headquarters in China. We were the first company to do multi-module microinverter. So a microinverter we can put multiple modules into the microinverter. And then ever since then, we've had a bunch of other products, including a rapid shutdown device, the three-phase native micro inverter. And then actually, very recently, we celebrated our 15th year anniversary. I think it was around February, I want to say. But for us, yeah, we've had a pretty long history serving our clients for microinverters. So we were hoping to have an additional 15 years into the future. Just as a quick overview, we sort of have two flavors of microinverters. Our first flavor is the AP Systems residential microinverter, which is the DS3. D stands for dual, S stands for single phase, and 3 it refers to our third generation of microinverter products. We have three versions of the DS3. We have the DS3S, DS3L, and the DS3 itself. They're all basically the same. The only difference is just the power output that they produce. The S is 640, the L is 768, and then the standard is 880. So the quick soundbite I always like to give is for the DS3 microinverter. It's possible to put two 550 watt panels to achieve a 1.25 clipping ratio on these microinverters. So they're pretty aggressive in terms of how much power they can handle. And that's something that we strive and design our microinverters for. In terms of the architecture, the way it works is that you have the microinverter itself, which is the actual device that converts power from the panels into AC power. Um, we also have a gateway device that we call the ECU, the Energy Communication Unit. That's the device that physically takes data from the microinverters via wireless Zigbee, and then it uploads the data through the internet. And that's either done through Ethernet or Wi-Fi. And then the third component also is our EMA, energy monitoring analysis application. And that both refers to the handheld mobile device app and the website that you use to access the cloud data of the system. So this is a powerful monitoring tool that allows you to see the data of the microinverters and also allows you to do remote control if you need to do any parameter changes or debugging related things. So this is for our residential solution for split phase or for single phase type solutions. And we also have a similar system, which is our commercial solution, which is we call it QT2. Q stands for quad, T stands for three phase, and the 2 refers to our second generation of our three phase microinverter. So we've been doing this sort of architecture for quite a while. Um, and the beauty of this product is not only is it a 4-to-1 microinverter that allows you to do a native three phase, so none of the whole if you have three phases, normally with a single phase inverter solution, you have to put one on each branch and you have to balance it. In this case, it's all folded into a single equipment, so you don't need to do any sort of single phase balancing, that type of work. Um, but the nice thing is that if you know how to commission our residential solution, the commercial solution is actually very similar. So similarly, there's an ECU gateway device that you can use to communicate with the microinverters. Sounds similar to the residential. And then you also use the same monitoring platform, which is the EMA, to go over the monitoring devices of the system. Main things I'll be going over is I'll first go over the main architecture of the microinverters. I'll talk a little bit about some new features, including the ECU updating procedure. Oof, there's actually a typo here. The other thing I want to mention as well is there's a way to use another feature that we've also released onto the EMA Manager app is something we call intelligent diagnosis that helps you as the installer to better debug systems to figure out where issues are. And I also want to go over a quick use case of using the ECU-C to measure consumption. We noticed that this has been a popular feature in Canada, so I want to do a brief note on how to achieve that. So first section, I'll talk a little bit about the key main reasons for using microinverters. I think the internal battle has always been microinverters versus string inverters. Obviously, I'm going to be biased because I work at a microinverter company, but I will mention that there's definitely a place and time for string inverters. But I primarily am going to be talking a little bit about more on the key reasons for microinverters. So the main thing I first want to stress is that in a microinverter solution, that is the true system that you're going to have low voltage DC. One of the big dangers of solar installations is high voltage DC arcing. Whenever you're dealing with high voltage DC, it is definitely a risk that you have to deal with. And I think we've seen a lot of really fun, oh, I don't know what's fun. I think it's fun. Of YouTube videos of like high voltage arcing on solar panels as you build them up, it can lead to these types of issues. In some cases, if you do the install with the highest safety standards, then it generally is not a problem. But if there's ever situations where you want to have that additional safety standard and you want to ensure that there's no high voltage at all, you can use a microinverter that basically allows you to make sure that the only DC voltage that you have is only going to be a single panel. So that's basically from a architecture way to guarantee that you won't have high voltage DC failures. Another point as well is it allows you to have not centralized points of failure. The one downside of a centralized string inverter is that if that goes down, then the entire string basically goes down. Whereas if you have a microinverter, in the example that I showed here with the QT2, where you have four panels into a microinverter, the worst thing that can happen is that if a microinverter fully goes down, then it just takes down four panels. So the failure is not as high under these circumstances. So that you can basically be more strategic in terms of when you want to go out to do truck rolls to figure out and fix systems. And also the penalty of a failure is also not as high as well. One thing I also want to mention as well is that you also get module level monitoring. Once again, this is not a feature that every customer is going to want. But if a customer does insist on wanting to make sure that they want to know the power protection of each panel, then I would say that a microinverter solution is the best way to do that because you can get current and voltage information for all of the panels. So as mentioned, these three use cases, eliminating high voltage DC for safety reasons, multiple decentralizing points of failure, and module level monitoring. All these things, all three of these things, are basic. How to say? All these three things are not going to be important for every project, but they can be useful for certain projects where you need to have those requirements. The thing that I always like to say is, in particular for commercial for QT2s, centralized string inverters can be is a lot more of a cost-effective solution from a BOM perspective. But then if you're working in a commercial setting where it's like a school or a church or something where you cannot afford to have any sort of safety risk, then a microinverter solution is really good for those types of solutions. So just from a connection standpoint, this is basically how the system is built together. So this is from a DS3, the actual microinverter itself. Let me see if we can pull up the. Um, Sorry, give me 1 second. Here's great, nice. I want to pull this a laser pointer over here. So this is the actual microinverter itself, and then these are the MC4 connectors where the panels go into. We refer to this as the AC connector, the connector where it outputs AC. Pretty self-explanatory. And then that basically goes into a bus cable. The bus cable looks like this, where it comes in spools. We have different spacing for spools, so if you need to have microinverters at a certain spacing length, we have 2 meter and we have 4 meter options. And then what you do is that when you take these spools, you cut it on both ends. On one side, you have an end cap that covers the wires like this. And then on the other side, you have a connector over here where you're basically you can either use a AC connector that you can purchase from us, which is screw terminated connectors, or you can use a simple J box just to terminate the wires. That's what we usually generally see actually in the field, and then that's basically how you do the AC wiring. If you have panels that are sort of farther away, you can skip connector and cap it like this. One downside of doing this way is you do waste a connector space here, but if you have scenarios where the spacing is a little bit different, then that's the way to do it. Um, Given the nature of the multi-module micro inverter, it's better to have panels that have longer DC lengths. But then if you have a connector that looks something like this, if you have a connector that looks something like if you need to reach a panel that's a little bit further away, you can use DC extension cables that AP systems that we do carry, and I believe distribution, and I think I think charge must carry these DC extensions as well. But if not, you can also make the DC extensions yourselves to be able to reach the panels further. It's also possible to use one panel instead of both channels. It's not the most cost effective way, but if you have an odd number of panels, that's also okay. You can use these DC caps to cover the MC4s like so. And the really nice thing is that for the QT2, it's a very similar scenario here. If you notice that all the components are basically similar, if not the same. I will actually mention I'm using an not up to date picture where the bus cable is actually it uses 5 wires as opposed to 3 wires. Because for the split phase, if you have L1, L2, and then you have Earth. But then for the QT2, you have 3 phases, L1, L2, L3, and you have neutral and ground. Note that neutral and ground is not necessary to be connected to the QT2s. So we notice that some utilities, I don't think I know of any in Canada. Most utilities don't make use of neutral and ground. And you only just need to connect L1, L2, and L3 to the connections. But in terms of parts, is very similar. You have the AC connector, AC bus cable, and so on and so forth. So I'll pause here. That's basically from the microinverter side. Any particular questions? If not, I'll move over to the ECU.
None in chat yet.
Um, Great, thanks, Brian. I'll move over to the ECU now. So the ECU is basically the communication gateway unit where it collects data from the microinverters and pushes it to the internet. We have two flavors of the ECU. We call the ECU-R and the ECU-C. ECU-R refers to residential, and this is what we usually use for residential type of solutions. So it looks like a very simple router, and it uses a wireless protocol called Zigbee to communicate with the microinverters. Um, and we usually say what is it? We usually say like 100. I'm covering 2 feet. We usually say like 150 meters is like the is a general good rule of thumb in terms of distance between the ECU and the microinverters. The ECUs also form like a Zigbee mesh network, so it's not like every single microinverter needs to see the ECU. As long as you see one of the microinverters, and then the that microinverter can see the other microinverters, that is going to be sufficient from a communication perspective. From a network connection perspective, you can either use an Ethernet cable, use a Wi-Fi connection. Cellular is possible if you have a cellular router, and that can be a way to achieve communication and remote monitoring through cellular, and that's an option. And then you can use the EMA Manager app, which is the app used for installers, or the EMA app, which is the app for homeowners to access the data on the system. Other thing I also want to mention as well is that we also have the ECU-C. C stands for commercial. I would say that it is possible to use the ECU-R for QT2s. So both of these are functional for both the DS3s and the QT2s. I would say the main difference with the ECU-C is that the ECU-C has a place where you can connect current transformers into it directly. Uh, and it's also used for both consumption monitoring and for export control. Um, and The other thing I'm also going to be mentioning is we noticed that there's been a lot of customers who's been asking, is it possible to get a consumption monitoring on a residential site? And then the answer is yes, it is possible to do that with the ECU-C. And I will show how that is done in this diagram over here. So once again, if you're using the ECU-C for residential consumption monitoring, the main things is one, from the power perspective, make sure that you connect L1 and L2 and neutral. Unfortunately, this graph does not show ground, but make sure you connect ground as well. But basically, make sure that you include both of the phases in order to properly measure power on both phases. One thing I've noticed in the field a lot of time is that with just the ECUC, they often just power it with just L1. But make sure that you also include L2 as well because we also need to get the voltage measurements as well to be able to see the readings on that phase.
So Christopher,
Uh,
there's a couple
yes.
questions coming through. So there's a
Okay.
question about like backwards compatibility for if your new models and future plan models, are they going to be replaced with a string or trunk cable that is new or using the same string or trunk compatibility? Like I know that the DS3 models plan to be around for quite a while. But if and there's a 4 model, would you think that would come with a different type of trunk, or would it be on the existing
Um,
trunk
I
infrastructure?
see. Yeah, that's a good question. So, for single phase and for three phase, we'll generally keep the same trunk cable design. So if we do have any future microinverter plans, our idea is to generally keep it to the same. But within our history, even with our older microinverters, we have changed trunk cable designs. Um, Although it happens very infrequently. I know, for example, the YC 600 and the QS1s, they use the same we call it the Y3 cable. But then we have used like other cables in the past. If there are scenarios where you have to use like a new quote unquote bus cable, what we generally send is well we would generally send like a bus cable and a equivalent connector. And then there's a little bit of work that would needs to be done in terms of like splicing and joining wire together. But that's in general what we would do if there comes a scenario where we have to do something along those lines.
Gotcha. There's two
Yeah.
more quick ones. So one,
Yes.
if the customer has like an older solar panel or is trying to retro or maybe upgrade an older site, how does the DS3S handle being compatible with like an older 230 watt panel? Is there a D rating, or how would you deal with being swapped into an older existing system or being used as a retrofit?
Yeah, that's a good question. So the number one parameter I always look at is the VMP, so the voltage that the panel operates at when it's pushing power or maximum power point. And the key thing is that that panel's VMP needs to be in between what our microinverter calls the peak tracking voltage range. And for the DS3s, it's 28 to I want to say 45. For in general, for lower wattage panels, the challenge that I usually see is that the VMP is usually pretty low, where it's much lower than 28 volts. And if that's the case, then those won't work with our microinverters. But if that older panel does have a VMP that is between the range of 28 to 45, then it will be able to work.
Okay, and one last question. Is the 150-meter between distance run, is that between the ECU and the closest microinverter or the furthest microinverter?
Closest microinverter.
Perfect. That was all the live questions right now.
Great, thank you very much. And once again, I welcome any questions that you guys have. And I'd rather have these conversations be back and forth. I think Brian had mentioned that if it was just it was just a continuous speech, it would be called a eulogy. I like that, so I'm gonna start stealing that for the future. All right, so coming back to the topic of consumption monitoring. So once again, first part is making sure that you have power connected and both phases are connected so that we can measure both phases. The second aspect as well is making sure that you have CTs that plug into that measures the production of the system and also the consumption of the system as well. And there's other points to make sure that they're pointing in the correct direction. For production, the dirty secret is the arrows don't actually matter. Because it's always gonna be positive. So just make sure that they're pointing in the same direction. For consumption, that one does matter. But if you mess it up, it's okay because we'll be able to reverse it on the back end for you. So if you need us to double check things, you can give our tech support a call, and then we can make sure to see if the direction is correct, and if not, we can switch it in the background in case you're not on site. Just the key thing is that making sure that they're pointing in the same direction. If you're pointing one in one way and the other in the other way, we won't be able to fix those remotely. Just make sure that they're pointing in the same direction. And then this is sort of an example of a system that's using such a system. The top graph basically shows the orange is the production. Because there's quite a lot of power, the consumption is the blue graph over here. It's relatively small. Any excess gets exported over here. And that basically comes in the difference. And you also get phase level power monitoring as well, so you can see the consumption of each of the phases as well. So yeah, that's going to be really helpful for these types of applications.
Okay, there's a few questions on the CT side of things here. So, given the ECU can measure grid CT and production CT, can the AP system derate the production to ensure the bus bars in a residential panel are not overrated? So, like
Oh yeah.
oversizing, but then reducing the production curve, essentially.
Yeah, actually, that's actually a really good question. So we call this feature export control, because you're controlling the export of power going to the system, and that is something that you can do if you have CTs installed. One thing I will mention is that for the three phase, that's not a problem to do. Uh, I will mention that for split phase, it can get pretty complicated because it's really hard to export control a single phase microinverter when you have a split phase load. because if you have a scenario where you have one phase that's producing more power or that's consuming more power than the other phase, there's a really hard. It's rather difficult for the single phase microinverter to sort of adjust for that, because it only has control over the sum of both phases. So we've seen in our experience that when you have a split phase export controlled system, it tends to be over aggressive in terms of controlling the solar or reducing the power of the solar system. So I will say that it is possible, but you will some. But if the system is not balanced for a split phase system, it is possible that it over controls or over limits the solar production.
Okay, then they want to know, are there specific specs for the CT? Can you use off-the-shelf CTs, or are there specific ones that are a requirement for a larger than 80 amp or 100 amp application?
Good question. So in general, the quick answer is use APsystems CTs because we have the CT ratio set correctly. The longer answer is it is possible to use higher rated CTs. The main thing is just that the CT ratio is just going to be different from what we normally use. I think it's on the data sheet. I want to say we use 3000 to 1 current ratios. But it is possible to use other current ratios. But the main thing is just is that you want to give our tech support a call because we're able to change it in the background. But we haven't opened it up to mainstream usage quite yet. But it is possible as a dirty secret. It is possible to change the CT ratio. You just have to give our team a call that you want to do something like that. The other thing also is to make sure that you use a CT that does not output voltage. It should be a current to current transformer type of CT. There are ones that output voltage, so make sure we use the current output ones.
Got it. And then there's just clarification point. So you can use consumption monitoring on residential APS systems now.
Yes.
Yeah, perfect. So
Uh, yeah, yeah.
some people are using third-party consumption monitoring software. So this would negate that moving forward.
That is correct. It would all be on AP system. So and the reminder is the way that is done is through this way, where you have L1, L2 both connected, and then you have the CTs connected to all the phases. And one thing I will say, there's two caveats. One, there are I'm aware of other third-party systems that are able to do like breaker level monitoring. This one is just a single entire house system level monitoring. And the other point also is that I don't think it's that. I believe the use case is mostly for end user knowledge. The accuracy of these how to say there's a standard called ANSI or revenue grade metering that requires a meter to have like extremely strict and extremely tested accuracy levels. The ECU-C does not have that. Is not ANSI certified and it's not a revenue grade meter. So which I think, but I believe this one is like plus minus. I want to say 5% accuracy, which I think is good for most residential use cases. But if there's a requirement where you need to achieve like extremely high accuracy, this won't be able to reach it. But I believe for most end users, it's going to be sufficient.
Perfect. That was all we had right now.
Great, thank you, Brian. Okay. Great. So the next feature I also want to announce as well is that we recently released a new feature that allows you to upgrade ECUs with the EMA Manager app. I know some of our customers have sometimes ran into issues where you have an ECU that's like low version, and you need to update it in order to talk to, for example, the newer fleet of microinverters or something along those lines. And in the past, we've said that you just connect it to the internet and it's able to update it automatically. But we recently got some feedback that it would be better to do it through a phone app, and we recently released this. If you have the newest version of the EMA Manager app, you'll be able to perform this operation. And just as an overview, what it looks like is the steps is one, connect your phone to the internet. 2, download the ECU firmware from the internet onto your app. 3, connect the phone to the ECU. And then 4, download the ECU firmware from the app onto the ECU. So what that looks like explicitly is, first connect it to the internet like so. And then number 2, when you open up the EMA Manager app, it's going to download the firmware from the internet onto your phone. The next step is then you want to take your firmware into the ECU, and that's done by doing local access mode. And then after you connect to local access mode, and you connect to the ECU, it will prompt that you want to have a upgrade, and then when that happens, you say OK, and then it's going to deploy the upgrade. And then once it's done, you can go in here to double check the version that is fully up to date. So yeah, and then so the idea is that we hope that this is a more faster way, and more, how to say, it's a faster way and more guaranteed way to ensure that the ECU is up to date, from a firmware perspective. All right, so I'll pause over here. Any particular questions regarding this feature? If not, I'll go more into depth on the intelligent diagnosing feature for the system.
We're good.
Okay, cool. All right, so for those who are familiar with the EMA website, there's been a lot of features with regards to using the module view to see the current and voltage information, looking at the heartbeats of the ECU to see if it's connected to internet or not. But we are starting to roll out a newer, more, I would say, uh, it's pretty intelligent, more streamlined debugging process to help you understand and quickly evaluate what is wrong with the system and what you can do to check rather quickly. And the idea is that we basically are dividing the three issues into inverter detection issues, ECU communication issues, and registration issues as well. I'm actually not going to go over registration detection issues, because for the most part, it's going to be either inverter or ECU today. But as we begin to update our alerting system, we'll also include I'll go a little bit more over registration in the future. But I think just for today's webinar, I'll be going over how the intelligent diagnosis system will be used to detect both types of issues. Where you can find the intelligent diagnosis feature is that if you go into the user page and go into intelligent diagnosis, and that's basically where you'll be able to see all that information. If all goes well, you get a really nice looking green smiley face to let you know all is doing okay. But otherwise, things are still okay, but it'll tell you, how to fix it. So the first class of issues I'll talk a little bit about are the ECU communication issues. The easiest way that we usually tell is that, so if you go into the intelligent diagnosis issue, if you have this type of issue, you'll see this error message where it says the ECU network connection issue detected. And then when it says offline, uh, if it says offline, then you know that the ECU is not is not able to connect to the internet, and it will indicate it as such. If it does have that issue, if you click onto that error message, then it'll be able to give you, and this is the case for every issue, it will give you a recommended solution. From here, it will let you know what the last reported time is, and then it will provide some options on what you can do. In general, it usually amounts to either the ECU turned off, either it lost internet connection because of internet connectivity, or maybe the router turned off. It's also possible that the password of the router had changed as well. So there's a couple of options that could potentially happen. Another issue is that the system has never uploaded data before. So this is possible when the ECU is live, but has never received any sort of power data in the past at all. And during those scenarios, and during those scenarios, oops, I went a little too forward. And in those scenarios, it's good to check not only the internet connection between the ECU and the internet router, but it's also important to see if the ECU is actually connected or talking to the inverters themselves. So that's another thing to just make sure of if you ever run into these types of issues. Um, Yeah, so that's from the ECU communication perspective. Next thing is that say you have a scenario where the ECU is connected to the internet, but there are just various inverter related issues. Here are some examples of what the intelligent diagnosis alarm feature will be able to do, will be able to find from a alerting perspective. So here's a scenario where you have inverters that are just disconnected from the grid. So say for example, so this happens. So say for example, you have a AC disconnect that you left open or something along those lines. And then during those scenarios, there's just no AC that's being provided to the inverters. But because, oh, actually, this is another fun fact. The inverters, they are powered and they will be able to communicate to ECUs if they're connected to solar panels. So if there's solar panels on the microinverters themselves, they'll be able to stay on and power on the microinverter, and be able to and they'll be able to communicate to ECU. Then they just won't produce power if there's no AC. The But then if you only have AC power, but there's no sunlight, or there's no panels connected to it, the microinverters will not be communicating to the ECUs. So during this scenario, that's why you will be able to see that a microinverter will be able to communicate with the system and denote that there's no AC voltage on the output. So if it knows that the AC voltage is lower than 50 volts for more than 30 seconds, you'll be able to see that on the graph. So as you see over here, there's a red section that highlights the scenario, the highlights the times where it reports 0 volts or less than 30 volts, 0 volts on the AC. So in this case over here, AC voltage is 0 if you look on the line graph. So if you have a scenario where it's like a single unit that is, or multiple units that are not on the same branch, then it's possible that there's an issue between the microinverter and the bus cable. So that's one thing to take a look at. It is also possible that if you see that there's many microinverters that are not producing power and many microinverters that also have this inverter off-grid alert, chances are that they're on the same branch and perhaps that there's a branch level issue. So some things you can check is if the bus cable itself is connected to the box. Maybe if there's a breaker that is open or something like that, or a disconnect that is open. Those are some things that you can check if it's like a branch level issue. Another potential issue is that if there are any sort of if the panels are lower than 30 watts for more than 30 days, and that's another possibility that you might have as well. Um, and it's possible that so it is entirely possible that this is intentional. There's some scenarios where you have an odd number of panels, and you are only using if you have an odd number of panels, and you're only using one of the channels. That is also possible. It will sound the alarm, but then if you were to delete that channel, then that alarm won't pop up. But chances are it is very possible that you added both channels into a system, and you had forgotten to remove one of the channels, and as a result, this alarm will pop up. So this is also another useful case just to do some cleanup to make sure that if you have a channel that was added by mistake, that you can go back in and remove it. Brian, so you have a question?
Yeah, is there a way to check the microinverter system is working properly as you're installing the system? So I guess prior to connecting to the ECU.
Oh, I would say in general, I would say I would set up the ECU and the microinverters. Well, I'll say this. It's possible to see the microinverters working very quickly if you have the ECU set up with the microinverters. So what I generally recommend installers do is during the beginning of the day, just turn on the ECU connected to the internet, and just have the microinverters synced into the ECU. And then what I would do is that as the day goes on, as I install the microinverters onto the roof, the ECU will begin to link up with the microinverters as they begin to build up. Um, and and they're still beginning to do the link up. And then as they successfully link up, you can use your app, do a local connection to the ECU, and you'll be able to see the data of the microinverters pop up as the sun comes on as they begin to turn on. A couple of caveats of this is that it does take a bit of time for the microinverters to sync up with the ECU, depending on the distance of the microinverters and the ECU. The data is also pulled every 5 minutes, so you won't see the data immediately. And the other thing also is that because of IEEE regulations, microinverters they can only produce power 5 minutes after they see AC. So you will need to wait a little bit to make sure and confirm that the microinverters are producing for each panel. That being said, we are working on something in the background where we do like a debug mode where you basically get the results of whether a microinverter is connected properly and is set up correctly. And we're doing developments and trying to basically make the ECU operate in high power communication mode, where it gets the data faster, so you'll be able to know more quickly if a microinverter has been set up correctly and is producing power. Um, I guess that's coming up in the future. And I'll probably give a we'll have some information and some future content describing this in the future. But yeah, once again, thank you very much for the question. Let's see. Yeah. Okay. So this is for low power alarms. Another type of alarms as well is inverter not communicating. So that's possible if the ECU, if the inverter is far away from the ECU, so it's not able to communicate, or maybe there's something weird with the with the ZigBee communication. Um, it's also possible that the ID is not entered correctly. So if we run into inverter not communicating issue, some things to check are the IDs entered correctly? Is the ECU close enough to the inverters? It's possible maybe no panels are connected to the inverter at the moment. It also could also be that this is that it's like a cloudy day, so there was just no sun at all, so there's no communication at this point. But if it's like something that is like systematically happening, that could be something that you want to take a look at and see if the inverter is not communicating for some reason. We're also able to identify if there are any we call it short circuit inputs where we see that the voltage is lower than 15 volts and we see a current that is higher than 3 amps. Usually in those scenarios, it's one of two things. One is that there is indeed something wrong with the microinverter, that there's a short circuit, or if we've also seen scenarios where the panel terminals are reversed, where positive went to negative, negative went to positive, or maybe the positive one panel went to the negative of another, or the positive one panel, or how do I say it, the whips of the panel got channel swapped, and that could potentially cause the currents to go in behave in a strange way. And in those types of scenarios, then usually we know that there's something weird with the wiring. But in this example over here, so the nice thing is that it highlights the section where it's red, where it notices those errors. And in those, so yeah, so that way you'll be able to know like during the times what times to see that you see those issues. So in general, if the system has worked before, it usually means that there is a short circuit inverter failure. So during those scenarios, it would be best to give a call to our tech support for RMA. We've also seen some scenarios where, like, if a grid is unstable, where the voltage goes over or something along those lines, that it also reports like an overvoltage alarm. And during those two scenarios, what we do in the background is that we increase the voltage range of the of the what we call AC parameters. These AC parameters are the allowable voltage ranges that the microinverter expects to see. It's usually done from a safety perspective and also is done from like a grid perspective. And a lot of times is that we work with the grids to determine what those limits are. But sometimes we see that those limits goes a little bit higher than expected. So in the background, what we usually do is that we expand those parameters to make the inverters produce power in a range that's more allowable. Brian, I see you have a question for your
Yeah,
friend.
you just answered the first portion of the question, which is great timing.
Oh,
But the
okay.
second portion is surge protection device recommended in these applications of variations and fluctuations of the grid,
Oh,
or lightning
I'm.
protection. Mm.
Oh, I see. I personally don't have much recommendations from a lightning slash surge protection. In general, what we usually say is so the biggest guidance that we usually give is more from like a continuous power rating perspective. Like from a breaker perspective is usually 20 amp or 30 amp breakers that we usually use. I'm a little embarrassed that I don't have like there's usually a maximum number of microinverters that you can put onto a breaker, and that's those are on the data sheet, but I don't have them on top of my head. So those are the things that we usually recommend from our side. The Yeah, so from a surge protection, I don't really have recommendations from my side. But that being said, it is something to be considerate of, especially during areas where you have high lightning strike frequencies. Um, yeah, for those, I feel like the better way is usually you have like a ground rod or you have like a rod that lightning usually strikes more often than like other things instead, and that basically redirects surge to other locations. So that's generally what I would recommend. I don't know if that directly answered the question. Uh, but from a over voltage voltage perspective, um, the microinverters do generally protect themselves from over voltages, and there are like stricter limits, and then there's like absolute limits. The stricter limits can be expanded in software and can be done in the background by our tech support. There are also conversations of us allowing that to be done by installers as well. And that's something that we're looking into making available. So if you do run into these issues where it over voltages, we're looking into having a way that allows you as installer to expand those ranges. Yeah, any other further questions?
That's it for now. Thanks.
Okay. All right. Okay, cool. All right, so that's for over voltage alarms. So yeah, in any case, those are the different cases of issues that you'll see. But the main premise is that in the intelligent diagnosis view, you'll be able to see a rundown of every single microinverter that could potentially have issues or something that you want to look at. Um, but uh, and that's going to be really helpful in terms of helping you debug a system and determine what to do with a particular product with a particular issue. This is old information, but I do want to briefly review this. But this is our system lights system. If you have a list of all of your projects, it will tell you it can give you a rundown of what the status is of each system. Green means the system is functioning normally. Yellow means that there's particular alarms with the microinverters, or might be some registration issues. Red means that there's an ECU connection issue. And gray means that there's just been no data uploaded from this ECU at all. So the first class of issues where we're talking about the ECU, that's usually the red ones. And then the yellow one where we talked about the ECU microinverter related issues, those are the yellow ones. So that's sort of outlined over here. Green is everything is normal. Yellow is that there's something yellow is there something up with the inverters themselves. Red means that the ECU is offline, and gray means that it has never uploaded data. Okay, so that's basically the end of the meat of the presentation. So once again, this intelligent diagnosis feature is both available for the DS3 and the QT2. Once again, the beauty of the microinverter AP systems architecture is that the process is very similar for both the QT2s and the DS3s. Because the ECU is very similar, and the EMA monitoring platform is also very similar as well. And you'll be able to get the same information for each one as well. So, in terms of just general things in terms of starting, we have monthly webinars, and Charles Hall also has their own webinars as well. If you don't have an email account, I recommend in registering for an email account over here. We have a bunch of product learning resources on the website. We have a YouTube channel where we contain a lot of. We have a YouTube channel that we contain a lot of information. This is our technical support number. We are trending more towards adding more local support to our phone lines. So our hope is that we are increasing our staffing for our phone lines, in particular for the Canada branch. So the number of people are is increasing. So our hope is that our response time and our response times are going to be steadily improving as time goes on as we're improving as well. So I'll
Do you
stop
have
over here and I guess I'll open up for any questions now. So yeah, go ahead, Brian. Sorry.
Yeah, there's one question in the chat, and I will just give people kind of last call. So please type your questions in now if you can get them in. But the one question coming through is, why would a normally functioning system have a consistent yellow light, even if the intelligent, smiley face says that it's good? Is there a reason why that would be happening?
Um, yeah, so I noticed that it might be good to file an issue if this is the case, because if you're saying that the intelligent diagnosis is green, but then the main page says it's yellow. Um, I know that intelligent diagnosis is a tool that we had recently rolled out within the last month. So it is possible that there's something that we need to work out the bugs into. I have a suspicion that it might have something to do with a low power micro inverter. Because I think the one thing that's challenging is that it's hard to distinguish if a inverter is not communicating intentionally, because there's something bad that's going on, or if it's just simply because it's bad weather, so the microinverter is just not producing power. So I think there's some kinks that we're working into this. One thing I just pulled out of thin air. Maybe it'd be nice if we included like weather or something like that that allows you to distinguish between those two types of issues. I think that's a further future future thing that we can probably take a look at. Yeah, I would say for your specific case, it might be good to file a ticket and we can take a look and see, because there might be some kinks that we need to roll out for this particular case.
Yeah, that's all the questions that we have from people here right now. So I'll just give a last call. Maybe give a minute here, and if nothing comes through, we will go from there.
Yep. Let me see. I can also think if there's any other random things I can plug while I'm at it. Actually, yeah, one thing I will plug. We are looking into developing what we call for people who are familiar with our QS1 product, which is a 4-to-1 micro inverter. We are looking into we're developing a QS2 right now, which is second generation of our 4-to-1 microinverter. So that is something that we are in the middle of getting certification for. And I want to say that we're aiming for it to be 1900, around 1900 watts. I forget the exact number, but it's the exact number that gives you the proper, that allows you to be under the 30 amp and 20 amp breaker rating on a full branch. Yeah, I wish I had the exact number, but that's something we're thinking about releasing. So yeah, open your ears and eyes to that because we'll be having that soon.
If the inverter is unresponsive, are we able to try resetting the inverter from the app or a PC?
Um, So if a inverter is not connected to an ECU, is not able to communicate with an ECU, one thing that we usually do to attempt to reconnect to an ECU is something we call is a network reset is a Zigbee network reset. And that's something that we can do that's something that we can do from tech support. So if there's like an inverter that's just like not just refusing to connect, and you're absolutely sure that that the ID is correct, one of the first things that we do is that we do a Zigbee network reset, and that's something that we can do in tech support.
Gotcha. Maybe just a holistic ask is, do you foresee any supply issues in the near future? It seems like the COVID supply, any issues there have kind of quelled, and supply has been very consistent. I know Charge Solar just landed a lot of inventory recently, so we don't have any short-term supply issues. But maybe just holistically, have you run into any inklings or anything on your end, Christopher, that you might want to comment on?
No, I would say our supply chain is quite stable. If you guys are curious, well, actually, it's not relevant to you guys as Canada, but as someone who's from the US, sorry. There has been some interesting conversations about like tariffs and things like that, and that has definitely impacted the actually, no, it has not impacted us. Because the microinverters that we send to the United States are from Vietnam. So they're subject to a lower tariff. But once again, not relevant to you guys in Canada, but it's a fun fact for the US. But that being said, we don't foresee any issues with regards to supply chain or anything of that sort.
This is a question that may be a little bit technical because I've not run into this before, but is the Chint monitoring is still a viable user option? So it looks like you used to have a
Oh,
export
yes.
power control ECU-R with Chint meter.
Yes, yeah, yeah. Actually, so yes, it's possible. Um, the the way that you do it is exactly what was described by the question. Is you have an ECU-R, and you have that connected to a chint meter, and the chint meter is like the interface that allows you to connect CTs to it and to do the export control or monitoring. I generally recommend the ECU-C because it's an easier install. But the chint meter, those are revenue grade and those are NC certified, so they're more accurate. So those are useful for those types of applications. I don't know if we sell those. It is possible to, how to say, it's possible to get, uh, I believe it's possible to get an off-the-shelf chip meter. But the main thing is that the connection between the off-the-shelf chip meter and the ECU, it's an Ethernet. It's through RS-45 and it's like an Ethernet connector. And the main thing you just need to make sure that you have the right pins connected.
Yeah, it looks online like you have a page that describes how to connect it. I think the question is more around, is this still supported? I think it'd be the main
Oh,
question.
it is supported, yes.
Okay, yeah, because there seems to be a page that explains how to connect it with the different monitors, and to your point, through the RS-485 jack and
Yes.
all that through. So
Yeah.
yeah,
Yep. Yeah. The main thing is that it has to be pin 7 and pin 8, if I recall correctly.
now we're getting technical. Yeah, yeah, you bet. It looks like we're at hour. We're at the top. Tatum, do you want to make any comments or roll us out here?
Yeah, thank
So
you, Chris. Thank you so much for the very informative presentation. We appreciate you joining us today and answering all the questions. Thank you to everyone who attended today as well. And as a reminder, you will receive the recording of this webinar by the end of the week. So thanks again. Take care, everybody.
thanks everyone. Thanks Chris for the presentation. That was great.
Thank you, everyone.